Okay, we are reviewing for the solving trig equations test. I believe it's algebraic manipulation number 5. And here is like the easiest thing. If you can't do this, I'm very scared for you. If it says cosine of theta equals 1, and it says, what are the answers between 0 and 2 pi? All the answers between 0 and 2 pi, where it can be 0 and it can't be 2 pi. Make yourself some little pictures and figure out what's the answer to that one. Again, you're trying to find theta. Okay, all students take calc. And cosine is adjacent over hypotenuse, so this is really like 1 over 1. And that's not a normal triangle, is it? Because the hypotenuse is 1, same as another side is 1, and that can't be normal triangle, so it's not going to be a triangle. It's going to be one of these, a quadrantal. So where is cosine 1? It's the same place where x is 1. And where is x equal to 1? Well, the x-axis is this guy, and x equals 1 is right there, and so it's that spot. Which should I say, 0 or 2 pi? 0, and 0 is the only answer, and it's it. Theta is 0. And is it 0 degrees? No, we're doing these in radians. So 0 is different than 0 degrees. And we'd have to say 0. There we go. Now, can this one crash? Could that possibly be an extraneous answer because it would crash this function? No, because cosine doesn't crash. All right. What if we ask cosine like this, cosine of some angle is equal to 2? It's not crashing, but is this possible? No, so you'd say no solution. All right, how about this, though? If I square this and say it's equal to 1, that's the next step up, because now it's squared. Now, you either have to factor it, or if you just want to take the square root on both sides, that'd be fine, too. Do this one quickly. Okay, so the deal here was to get rid of cosine squared. Here's how you'd factor it. You just got to set everything equal to 0, right? So you just move the 1 to the other side. So it equals 1 like this, right? So I subtract 1 from both sides. And now it equals 0. And then I could factor it. Cosine theta plus 1, cosine theta minus 1. And now I could set those both equal to 0 and say cosine theta plus 1 equals 0. Subtract 1 from both sides. Cosine of theta equals negative 1. And over here, add 1 to both sides. Cosine theta minus 1. Minus 1. Oh, this is getting ugly. Minus 1 equals 0. Add 1 to both sides. Cosine theta equals 1. Now, was there a faster way? Yes. I would say there's a faster way than factoring it. I'm not done yet, by the way. I'd have to find out the two answers, the spots where cosine is positive and negative 1. But, go back to here. Just let me show you how much faster it is to just go like this. Here is my original problem right there. Okay. Square root. Square root fixes squared. And then it's going to remember this is the absolute value of cosine theta. And the absolute value leads me to say cosine of theta is equal to plus and minus 1. Does that ring a bell? We've done this so many times now where you have square root of a variable and you need the absolute values and everything. So then it's two things, cosine's 1 and cosine's negative 1. So you write it out once, cosine's 1, and then cosine is negative 1. I think that's faster. But if you want to factor it, it's totally fine too. Now factoring can break down though, because like for instance, cosine of theta is equal to 1/2. Sorry, cosine squared theta equals 1/2. That one would be very hard to do with factoring. You subtract a half from both sides and you'll have this. But is 1/2 a perfect square? No, so it doesn't factor nice. So you better be able to handle it without factoring. So what would you do here? Just like last time. Square root, and do square root, absolute value of cosine theta equals square root. And this, a lot of people get confused because they're like, I don't know those numbers. I've never seen those numbers before. Yes, you have, because the square root of 1 is what? 1 over the square root of 2. Does that ring a bell? Is there a triangle that we know that has 1s and square roots of 2 in it? 1, 1, square root of 2 triangle. You've seen that one before. All right, so the square root of a half simplifies to this, and that's important to be able to handle. All right, then I'd have plus and minus because it's an absolute value here, right? So cosine of theta is plus and minus 1 over root 2. So I got to do it once with plus and once with minus. And again, I've already talked you through the process of, finding all students take calc, figuring out where is this positive or negative, etc. All right, next thing I want to talk to you about, what if there's 3 kinds of factoring you got to be able to handle. This kind, cosine squared x plus 3 cosine x plus 2 equals 0. This one's kind of nice because it's already set equal to 0. You don't have to even finish this whole problem, but just factor it for me. Make sure you know how to factor that. If you need to, you can simplify it down to just x squared plus 3x plus 2 and factor that. Because it's kind of like that. Do you agree? So then, is the answer to this one -2 and the answer to this one's -1? Agreed? And then I got to put in cosine. And then, wait a minute, how do I do that? I don't, because what's the lowest cosine can ever go? -1, it can't go to -2. So this one is no solution. There's other ways to write it, yes. Okay, but I'm trying to shorten it, and I don't know how to shorten a solution. But anyway, that one's not going to work. That one I can still do, though. Where's cosine -1? It's like saying, where's x -1? Right? Because cosine's like x. Where's x -1? The x's are this way, and so the x that's -1 will be right there. So it's out there, and so what's that? Pi. Right? And somebody might be going, why weren't we doing that all students take calc thing and figuring out where cosine's negative? Because this was a quadrantal again. And I'm not going to draw a triangle. What?
Can I go on field 6?
Yes, go. All right. Okay, we're going to move on to a different kind of problem. This kind, can you factor this? Try factoring that. Did you get that? Sine came out of both of them. All right, then you just set this equal to 0 and set that equal to 0. And you get a bunch of answers. Okay. Just for a moment, sine equals 0. I'm going to just finish this. Where y is 0. And y is 0 here and here. Remember, I got 2 answers, 0 and pi for that. Because y is 0 at those spots. But notice I did not say 2 pi and pi. Why? Because those directions always say between 0 and 2 pi. All right. Over on this other side, sine theta equals 1. After I add 1 to both sides. And then where is sine equal to 1? That's like saying where was y equal to 1? Y is equal to 1 right there, and so it's pi over 2. And there'd be 3 answers. Pi over 2, 0, and pi. Anytime there's a lot of answers, I make sure that none of them are like extraneous. How would one of them crash? One of these is one of those things that makes something crash. What's the thing that can crash? Tangent. Is there any tangent in this problem? So I don't have to worry about it. There was a tangent in the problem. Which is the angle that would have crashed? pi over 2. Okay, good. Next, if you are asked for, this is the only thing that I asked Mr. Winterhalter if he had a chance to teach you, and he said he did not, and it's a simple thing. Instead of saying all solutions between 0 and 2 pi, what if they just say all solutions? You get on trig, they're waves, and so they keep going, and there's an unlimited number of answers because you can keep adding 2 pi to it. Like on 2 pi later, it'll always repeat. 2 pi from now, it happens again. 2 pi from now, it happens again because that's its period. So wherever the spot is, it's going to keep happening every 2 pi. So prepare to learn something new. If they just ask you for all solutions, and they don't say between 0 and 2 pi, are you really supposed to list every solution, which is an infinite number? Of course not. But each of these solutions will repeat every 2 pi. So you say plus 2 pi n. I heard one teacher, math teacher, say he uses 2 pi k. Doesn't matter. N can be any number. In other words, 2 pi times 1, or you can add 2 pi times 2, or 2 pi times negative 1, or 2 pi times negative 2. But anyway, if you say plus 2 pi n on all your answers, you're showing that you know if you really want all solutions and you don't make a little list like between 0 and 2 pi, there's no like limits, then you have to say plus 2 pi n on your answer. Okay, so watch out for that. And we even, in the directions, when we say, you know, because most of the problems are not that way. Most of the problems are between 0 and 2 pi. So if it's ever just all solutions without the 0 and 2 pi, we make it really clear. All solutions. It's like really, you know, bold or capital letters or something. We'll make it clear. You just have to understand if it's really all solutions, you aren't going to be listing them forever. You say plus 2 pi. And you can't just say plus 2 pi because that would only be one extra solution. Plus 2 pi n, where n can, and you don't have to write this up, but where n can be any integer. Yes? Good question. Plus or minus 2 pi is a way to do it, but again, I talked this over with some math teachers, and if you say plus and minus 2 pi n, then that's assuming n is only positive numbers. What if n can be negative numbers? Then I don't need to say minus 2 pi. But you're right that, you know, these waves go forever, and some people think of plus as only going that way. But if you add a negative number, you will go that way also. Okay, so by saying plus 2 pi n, that is fine. Now, I would also accept plus and minus 2 pi n. I would have accepted that. Did you see that on a key somewhere? Or how did you know? Ah, okay. Yeah, I know what you're talking about now. Yep. All right. And if you had defined your n as being positive or negative numbers, then I'd have had to give it to you. All right. So anyway, plus 2 pi n. I just like changed my opinion on that last week. Otherwise, I was always doing plus and minus. But since n can be negative, do you get? You don't really have to do the negative parts. Okay. Anyway, so just when they ask for all solutions, that means plus 2 pi n on any answer you would have. Okay. I think we've done enough. No, wait. There's one more that I want to do. There's one more practice problem. You know, I'm going to do that on your worksheet, though. I'm going to do one of your problems with you. Okay, so here comes the review. Now, you know, sometimes people get, you know, like it's hard to motivate yourself to study for this test or that test. Remember, you just came off of a test where a lot of you got C's and D's, almost everybody. This is a test where you could easily pick up at least a B. Okay? What I'm trying to say is it's a really good time to get a decent score. Here's the other thing. After this test, we review for the cumulative test. So by reviewing really well tonight, doing a really good job preparing, maybe coming in the morning if you need help, I'll be here. You're being smart because this same stuff you're being tested on tomorrow is going to be on the cumulative test too. And wouldn't it be nice to knock it down right now, get it totally, under control tonight, get a good grade on it now, and that makes it easy on the cumulative too. Because many of you need to really focus on studying for the last test over again, because you're going to want to use your cumulative as a retake for hopefully not this test you're just taking. Yeah, there is a cumulative coming, but you really better study tonight so that this can be solid, because that other part is still really hard. And I'd like to study for that with you later, but not today. Today we're going to focus on solving trig equations. Okay, I'm going to have you skip 1b and d. 1a, right off the bat, they are testing you on whether you remember what sine of 2x is. Do you remember that that's the one you had to memorize? How many of you are confident you know that one? About half the class. Okay, somebody that is confident, tell me what it is. 2 sine x cosine x, yep. So you just sub that in, minus cosine x equals 0. There's my equation now for problem number 1. 1a. So now I see cosines in both of these, and if you can factor it, finish it. If you can factor what? You should. So I'm going to factor those cosines out to the front. And now this part can equal 0, and you'll have maybe 1 or 2 answers for that. And this part can equal 0, and you get 1 or 2 answers for that. Can't draw a triangle if one of my sides is 0, so I know I'm on a quadrantal. Wait a second. Is it? Okay, I'll go ahead. Do you get that the original problem on this said sine 2x, and I replaced all this instead of sine 2x? Okay, so you get that part. All right, then the next step was, do you get that there's cosines in both parts, and therefore I pulled them out to the front? I'm just factoring a cosine out of both of them. Okay, so now I got it down to, it was factored in. Once it's this times this, if it's a multiply and equaling 0, you're all set up. Because that's what you want every time, is the ZPP property, where two things are getting multiplied, this times this, equaling 0. Then you're all set to set each of them equal to 0. So now cosine of x has to equal 0. Where is x? Okay, cosine is x. So where is x equal to 0? S is equal to 0 here and here. Those are two spots where x equals 0. Right? You guys agree with that one? Was it pi over 2 and 3 pi over 2? I think so. All right, and on the other one? Oh, I finally have to actually draw a triangle. Sine is equal to a half. I know that one. That's 30 degrees, also known as pi over 6. But if you just stop right there, you've eliminated one of your two answers, because sine is positive in two places. All students take calc. Sine is positive on the top two, so these two are gone. So there's another answer over here, and that's a bunch of pi over 6s. So pi over 6 is this first answer. Then there's a whole bunch of pi over 6s to get you to here. Specifically, how many? 5 pi over 6. So it's 5 pi over 6, and pi over 6, and pi over 2, and 3 pi over 2. Now, when you're done with an answer like this on the test, I'm going to ask you to write them in order from smallest to biggest, because it's just, you're less likely to forget one, and I really want to make sure that I'm, giving you credit if you got all 4 of them. So the smallest one was pi over 6. The next biggest one was pi over 2. If you put them out of order, it's not like I'm going to mark them wrong, but if you can put them in order, that would be nice. There's my 4 answers. Okay. I know, that's a lot of work to show on one problem. All right, let's do another one together. What does J have that's special? Something more special than cosine. Tangent. So as soon as you see tangent, it should be like, oh, ooh, that one might have that little issue. How about part C? C is in cat. See, that one's got a tangent in it too? Anytime it's tangent, it's sort of like you got to profile those questions and say, oh, that one could crash. Is it for sure gonna crash? No, but it could. Tangent's the only function that can crash. Let's do C. 1C. All right, there's tangents on both sides. Can't I just divide by tangent on both sides? Yeah, I can. Nothing wrong with that. Or I could have subtracted tangent from both sides. And then did this. And I'm going to subtract tangent x from both sides. And then factor the tangent x out. If you can factor, you should. So now I got tangent x equals 0. The other way I wouldn't have. So what's right? Square root, holy cow, this one's going to have plus and minus. Sine x is in absolute values, and I get 1. And then I get it out of the square root by going sine x equals 1 and sine x equals negative 1. And then I have to solve both of those. So I got this one and this one and this one. You know the reason that you really shouldn't divide by tangent x on both sides and have it cancel is that you'll forget that there's a tangent in the problem. Because one of these answers that you get when you find those answers, one of those answers is the thing that makes tangent crash. So it's not that tangent's going to crash right here. Tangent can be 0. When is tangent equal to 0? That's when y over x is equal to 0. When is y over x equal to 0? It's when y is equal to 0. When y is equal to 0 is here and here. Those are spots where y is equal to 0. So those are spots where tangent is equal to 0. At 0 and at pi. If I wanted to make a picture of tangent to sort of see why that is, here's tangent, and here's pi over 2. And you make another one like this, and this is pi, and this is 3 pi over 2. And at pi, it's hitting again. It's hitting 0 again. So tangent hits 0 at 0, and it hits 0 at pi. 0 and pi. So just trying to show you another way to think of it is with the picture, with the graph. All right, so my answers are 0 and pi, and then this one has an answer or 2, and this one has an answer or 2, and I just am warning you that one of them that comes out from those signs over there is going to be something that crashes tangent. And therefore, you better not say it's a solution to this whole problem, because if an answer of, again, the two things that crash it are either pi over 2 or 3 pi over 2, if those answers come out and you say that it's the solution to this, you're wrong, because tangent of that angle will crash. All right, I want to let you finish that one, see how that comes up naturally on your own. Let's go to the back side. Number 2, part Let's just do A. Number 2A. Notice the directions on this one. Find all solutions. Does it say between 0 and 2 pi? No. So on the top of the page there, why don't you put plus 2, what's that thing again you're supposed to add? 2 pi n. Good. All right. So if we say for 2A, it's 4 cosine squared x minus 4 cosine x plus 1 equals 0. Then I'm going to make it simpler. 4x squared minus 4x plus 1. I like to do my algebra the old-fashioned way with just an x. So this is going to be a 4x, and this is going to be an x. And this is going to be a minus 1 and a minus 1. I'm pretty sure I did that right. How do I tell? I go first outside and inside last. First makes 4x squared. Outside and inside makes negative 4x, and oh, that'd be negative 5x. That's not it. I did it wrong, because the outside and the inside don't make the middle term be negative 4x. Okay, so then, oh, I must have to split up my 4x into a 2x and a 2x. Is that right then? No? I'll double check. First, make 4x squared. I was okay there before. The outside and the inside now make negative 2x and negative 2x, which makes negative 4x. Yay. I can factor. Okay, so now, since they are identical, you really don't have to do it twice. That'd be dumb. So we just say 2x minus 1 equals 0, and then 2x equals 1, x equals 1/2. And then, since we substituted a cosine out, now we got to put a cosine back in. Cosine of x is 1/2, and let's see if you can finish it from there. It shouldn't be too bad. All right, if I were you, I'd work hard on this worksheet. We got about 20 minutes left in class. Ask me questions if you get stuck. Know how to factor. Know some of your basic substitutions. Like if you can't handle, like what's 1 minus cosine squared, you will die on this test. You have to be able to do basic substitutions like that identities test. So if you're like, I don't know which one that is, just memorize, at least, wouldn't you agree there's lots of squareds going on? So you better know the one with the tan is, what's that one? We seek. And the one with the coat, what's that one? What's the one with coat? Cozy. And the last one is sine squared plus cosine squared of theta equals 1. So if I say 1 minus cosine, that's like, oh, I just moved this over here, and that's the same as sine squared. Yes, ma'am. I did say to skip B and D. Only because I'm trying to make your assignment a little smaller. If you want the practice, do them. Especially because one of them has tangent in it, which means you should notice there's a chance that it could crash. Actually, both of them have tangent in it. B and D were skips. Oh, actually, just on the front side is what I was intending. Let me look at the back side and see if they're. 2B should be easy, and I think you should do 2D. I guess I could live with you skipping 2B. Really doesn't matter. So I'll say that. You can skip B on both sides and D on the front side. Okay. The rest of the time is yours to work. Study hard. Do well in this test. Make up for a bad grade last time. And then the homework for tomorrow night after the test will be starting the review for the cumulative, because we only have 1 day of review for the cumulative after this test. And then the cumulative happens on Thursday and Friday, because the cumulative is big enough and scary enough that we wanted to divide it into 2 days. Okay, so we got a 2-day cumulative test. That's also good because you can study in between too if you want to. So, okay, that's all I got for you for now.